We were talking about the two different cases where, like, at medium.com, you can pay one subscription, you get access to all the premium content, but like Patreon, you only get access to the artists who you're sponsoring. You don't get like all content because you sponsor somebody.
One question about the protocol. If it is a private, how it's supposed to, how we can force it that it is a private entry, just push it there. How we can force it?
It's not, we're not pushing anything. It's the way capabilities. Yeah, exactly. So it's the way the app would be written. It's like you would have a draft space or whatever, and then when you click post on your article, that's a subscriber required article, then it's going to send, instead of publishing to the DHT, it's going to send to these hosts, right? And then these hosts are holding it as private entries in their source chains, but showing that it was sent by the other person, right? They're still they need to create a data structure that shows who the author was and who sent the node, who sent the data. And then we create a capabilities token. The capabilities token basically says,
each of these nodes creates a capabilities token for the author. He then goes, I'm going to claim I'm allowed to do this, and then the node checks that the capability is correct and allows it to be saved as a private. Yeah, I did that as well.
It's like as a white tip.
It's an eraser.
It's an eraser?
Ah, yes, eraser it seems. Try to
It's
erase?
just a marker with no name, I think. Anyway, so the structure of a capabilities token, this is all built into Holochain already. It's the security model of Holochain, right? So the first capabilities token is the thing that you think of as your identity entry. So you know how a source chain entry first has the DNA,
yes,
right?
Yes.
And then the second entry on it is your ID, right? And so these things go up to headers. Your ID entry is actually now, it didn't used to be, but is now a capabilities token. It's basically saying, this is the public key of the private key, counterpart private key, who has the capability to write new entries to this chain. Right? So this is a permissions model where actually you're giving yourself permission to write to this chain. And it has to be created explicitly. So that you can create other entries that say, wait, let's say we create a private entry here. I'm going to make this a dotted line for private entries. And so this is a post. It's private. I can then create another private entry that is a capabilities token that says that this other ID, another ID, your ID, this is my post, and I'm going to give your ID the ability to read this other post. Right? So we'll talk about the structure of the capabilities token in just a second, but this is basically how it works. And then what I do is I give you back the hash of this entry, which is visible here in the header, right? But I give you back the hash of this entry. And so when you want to read this post, you do a send receive with me and say, I'm passing this token, and what this token allows you to do is read this entry.
Your private entry.
Right. So I respond then via the send receive by giving you that capability. So the structure, by giving you the entry. So the structure of a capabilities token is you say basically which keys, right? So this is a set of keys. It's an array of keys that who has this capability, and then you basically are saying what. And what this is an array of functions that they can call, and those functions may be parameterized already or not, meaning you may put a parameter in it, like I can put this post ID in it. So I'm basically saying you have the ability to read only this post. Not all my private posts, but this capabilities token, I can actually hard code the parameter that this capabilities token is giving permission to read this post only. By being able to, what's that called? I always forget when you pre-fill parameters in something.
Defaults?
Pardon?
Like a kind of a default?
Yeah, no, it's not there's a certain word for it. I always forget the freaking word, sorry. It's a computer science term of when you, it's like on the tip of my tongue. It starts with a C maybe. Anyway, it's something that would normally take parameters, but you've hard-coded certain parameters in it so that they can't be changed. So this is no, it's not a constant. It's a thing. Who cares? So this is the structure of a capabilities token, essentially. There's one more piece which is a little bit weird, and I'm not even sure it's working yet, which basically says whether the capability is transferable or not.
It means I can give it to another.
Exactly.
I can grant it.
That is a possibility.
Oh.
Yes.
It is or not.
That's what this is for, is to say whether this capability is transferable, whether you could share it with somebody else and then they would now have access. Right?
In that case, it means for a subscription, we need to create a one capability and just give to it another guy. That's all. Yeah, it means we are sharing the capabilities.
But then anybody could share it to anybody else without paying the subscription.
It is also.
So that's not necessarily the best function. So in this scenario, what you want to be able to do is these host nodes want to be able to call a function that checks to see whether there's a subscription in place. And if there is, then it provides the private content. So they're basically going to have a capabilities node that filters to private entries, and it's going to basically do a subscription lookup. So depending on how you're trying to structure your subscriptions, if you're trying to do a subscription per author, for example, like am I subscribing in general, like with medium.com right now, you can subscribe for premium content, but that's all premium content, right? So that's one approach. Another approach could be I'm subscribing per author. I want access to, like Patreon, you know, you sponsor particular artists and you get access to their content. You don't get access to all the artist's content.
You mean the different resources, permission based on the different resources.
Well, you have to figure out what your subscription model is.
Actually, we talked that I think you need to join. You are in the good moment that you need to help.
Okay.
So we talked about the subscription that at first. That is it a good idea to go for that because we are in this point that
It doesn't matter. You just have to choose whether you're doing a subscription to all content or a subscription to selective content, so that your capabilities token, the function that you're calling, is checking whether you have that author's subscription or whether you have the premium subscription to all content or whatever it is.
Kind of pull it back even further now because that's like you don't even need to add money to a subscription. Like it could just be as simple as I'm following you like on Instagram. So that's like I ask to follow you, then you accept or reject that.
Sure, you don't have to have payment involved.
Yeah.
But that would still be the Patreon model without a payment. That would be you don't get access to all the content, you get access to my content.
exactly.
So what would be an example of all the content?
Medium.com, where Medium holds certain articles as premium content.
I didn't even know that.
And you get to read like 2 premium articles a month or something like that
the
for free.
newspaper, like New York Times or whatever.
Exactly, and then if you want to read more than 2 articles a month for free, you know, then you have to subscribe to their premium content. And they're trying to get their writers who get a high amount of views to make their entries premium so that they can get they keep asking me to make my blog posts premium, but I don't want people to have to pay to read my blog posts, so.
It's kind of a meta premium, like for all the premium articles. You pay one fee a month.
Exactly.
And then you have like for users, then you get the user, but you can also have a subscription on article on a single
Or a single author.
or a single article.
You could also do a single piece of work if you wanted to.
So you're saying to do that, you just grant a capability to the.
Saying you would write a function
Yeah.
that looks up your subscription, that looks up whether you're subscribed, whether you paid or didn't pay or whatever the thing is, but whether you're subscribed. And it looks up the subscription check function, the subscription lookup function would have to be looking it up based on your subscription model. Are you subscribed to this author? Are you subscribed to this article? Are you subscribed for premium? Whichever your subscription model is, your subscription function is going to be the thing in the capabilities token, right? So then when people call into these hosts, into the private entries to read the subscription only entries, right? You're going to have a transferable token because it doesn't matter who's calling in. You're going to look and see, is the caller subscribed to whatever it is they're asking to see?
And this happens every time they try and open the entry.
Yes, because they're private entries. They're not on the DHT.
And just to
You
clarify,
left the room and missed all that.
Yeah. So I think
There is
it's
a
like
video
completely
excellent.
different. That's what I was talking
I
about.
really like this. I think this is cool.
So you're clear, right?
I think so,
That all
yeah.
makes sense to
I'm
you?
doing a sequence diagram so we can see
Sweet.
exactly what's going on.
Yeah, just to clarify, what is
Yeah, but video.
token? Is it like a type of entry, or what is the specific data structure? of the
Capabilities token is a type of entry, yes, that exists. Your ID is the very first capabilities token, and it gives you the ability to author. So it gives you basically all of the functions. It gives you the ability to author to the chain, right? So this is done in the Genesis process. If we didn't give you those capabilities, then you couldn't write to your own chain. And then there's also public capabilities, which we generate by default based on which functions you've declared as public. But yes,
So this is nice. This also gets around like the editor, publisher kind of process as well. So now the author can go, right, written my article and then post it to Hum,
yeah,
but it's in a different type of private entry that's not published. And then when they go, yeah, that's a good article, they can then move it up, or they can publish it into another type of private entry, which is in that list of things that can be accessed by subscribers.
yeah.
And how is the flow is supposed to be working? When a guy is gonna go come, we are not delivering the capabilities. He's gonna claim, and the process behind, we are going to send back the capabilities. It's going to send to the host and read. Yes.
Mermaid sequence diagrams.
So what happens is capabilities tokens have two parts to them. The part that we're talking about on this chain here, this is my DNA, this is my ID, this is the private post I wrote, this is the capability token where I gave you permission. This is what we call a capabilities grant.
Okay.
When I gave you this permission, you are going to store the other side of this on your chain as a record, which is a capabilities claim,
Okay.
right? The capabilities claim tells you how to ask me later for this private entry, right? So basically, when Tom decides he wants to follow Loic. Oh, it's a K? No. Loic's content, he grants you a claim, he stores a grant and gives you a claim, which is what lets you make claims on that content. Basically, when you do the subscribing, you get the key that lets you ask for the subscribed content.
What happens if he goes offline and then you don't want to claim?
That's what these hosts were for, is a
Yeah.
place to share your data to some hosts that promise to be online.
This is the outside of the DHT.
They store it as private entries on their chain, but they promise to be online basically as much as possible. And if you have, for example, 5 hosts that are online at least 50% of the time, you have over 5 nines of uptime.
But these are trusted because they can actually read it.
They can actually read it, it's on their source chain, yeah.
They're probably going to be hollow instances.
It could be hosting instances or
Or your own.
your own,
Yeah.
yeah.
And so who is gonna be the issue? It is in compare of a JSON token. So it's
Like a JSON web token, you're saying?
Yes, in compared to JSON web token. So it means it's gonna be valid for a period of time. Anytime we are going to issue a new one, that just we are saving something here that says it is for this one.
Yeah, so I don't remember if we put a date in here, like an expiration timeline. We might have put that in there. I can't remember if it's actually implemented. But like any entry, you can delete it or update it. And then the entry gets marked deleted or updated. Now, it's still in your chain, but you can check the status on it to see whether the capability is still good. If I gave you the ability to read this private entry, but then you did something which broke my trust or whatever, I could revoke this capabilities token just by marking it deleted.
When you access then the function, then it will say, okay, it's not.
Right. Because if the capability is deleted, you don't have it anymore. Even though you still have the claim, it will reject it when you ask me to exercise the capability.
Okay.
Does that make sense?
Yeah, and so how it is validating me? I'm also always I'm saving my actually this token.
Claim. You claim saving the token.
Or any time on time I need to ask, I receive and then claim.
No.
I can save it, yeah, in my.
You save it. You save the claim.
I save the claim.
Yes.
So
that you can always use that claim.
Okay.
Because the intention is that these claims are probably not only for one item of content. It's like the subscription item, right? It gives you access to all my private posts, all the private entries of a particular type, for example, is the way you might write the function that's in here to check and see, are they subscribed? If yes, then are they in my list of subscribers, right? And then if yes, so I could write one token. I don't have to give you a different one every time, right? I can write one token that has a function that says, if they're in my list of subscribers, they can read my private posts.
I see.
Only posts, only blogs, not my private everything, but only, And so then when you subscribe, what I actually do is I add you to an entry, I edit an entry that is my list of subscribers. So that this thing checks that list. And if you unsubscribe or your thing expires, I edit the list and I remove you from the list. And when you try to check, it always checks to see if you're in that list.
And that's in this function. Like
You would write that, that's the way you would
you
write
have to
this
put that
function.
in before the fact. You can't go in later and say, like if you just give them a thing that says you can access all my posts and there's no check for like deleted or.
Then that token would give them access to all the.
Yeah, and there's nothing you can do to revoke that then.
Well, you could revoke the token.
How can you revoke the token?
Because the token is a private entry on your private chain that gives you gives somebody access to private things or any
So
functions.
if you put another entry in saying this token is invalid or revoked or whatever.
You just do a delete on it.
Yep, and then anytime they call that function, Holochain's going to check that.
Correct.
Still
Kind of a,
Go ahead.
it's a kind of a subscribers table in a.
Yeah, that
What
would
you
be
check
the list
against.
that I was talking about
Yeah.
would be a subscribers table. So instead of, I don't give you one special token for only you, I give you a subscriber token, and I have something that checks my subscriber list,
Yeah.
checks to see if you're in it. So when you subscribe, I just add you to the list and I send you back my subscriber token. So I don't have to manage.
And then you just
Hundreds
do
of
like
tokens.
an update on that list.
Exactly.
And you
Yeah.
can be in it. Yeah.
How do people subscribe? Is it like, is it because I was thinking the pub sub pattern, so someone can publish something and then they can subscribe to that or like a topic.
Well, to me, this is now, this is the problem with the word subscription, right? There's a lot of ambiguity. What I was understanding was that they really want this to be an allow deny filter. This isn't just a pub sub pattern of which things am I listening to. They want the person to be able to specifically say, I'm allowing you to listen to me, right? So this isn't just pub sub, like you can sub to anything you want, and the person on the other side actually has to grant you access. In this story, this is what we're talking about. For capabilities, you don't need capabilities tokens for public access in the DHT. In that scenario, you could, like from the tagging project, you could just say, I want to watch for anything that's tagged whatever, and now you just look for new links being added onto an anchor, and then you can see, oh, there's new entries about currencies or whatever, right?
Yeah, that's the mechanism I was wondering how they become aware of these things. If they
Yeah.
look for new links, you just have a mechanism to search for new links.
Yeah,
So
New
we
links
know
off
there's
of,
new.
off of an anchor that you expect to find a link from. That would be the pub sub type of pattern. But that would have to deal with DHT, like already published content. This is content where you're trying to manage a membrane of who can access it and be able to take away access. You can't really take away access.
It's like access control, kind of. You can do it on create, read, update, delete.
Yeah. So the thing is that capabilities tokens they give you the ability to construct any kind of access control you want, essentially. And I think I would assert them far more secure than access control lists. 'Cause you can specify exactly who can call what functions and pre-parameterize those functions, and
in this
it's cryptographically signed.
you have to also tell all your other nodes, hey, I've taken this person off the subscription list. Like if you just change your source chain, it's not good enough. Like
No.
all these would have to know about that, right?
No, because your subscription list could be your subscriber list could be on the DHT, and you're just the only person allowed to edit it,
Okay, that makes sense.
right? But does it matter? I mean, are you trying to keep private who's on the list?
I mean, you might. If it's like a list of who's going to go to the protest or whatever.
Yeah, I mean, you might. If that's your use case, then you may not want to make that public. But for this type of scenario, it's probably fine to make it public.
And in terms of the data structure, so the subscribers, so the claim is just when I'm receiving the grant. So I'm saving it for, or what is the claim actually? Is it
So the claim is basically you storing the command that you're going to send and the token ID. Think of it like your API keys, right? If I give you the ability to call into my system, I also give you a set of API keys to authorize that it's you making the call, right? So essentially, the hash of the hash of the grant is your API key. The grant tells you what API functions you're allowed to do. And if it's not transferable, it has to be signed by one of the keys that I've authorized to do it, right? If the message that comes in wasn't signed appropriately, then you don't get access to the function. So this is basically the core building blocks of Holochain's security model that allows you to compose whatever kinds of permissions you want to compose.
Thanks. Is this a pattern you kind of invented?
Capabilities are not a pattern that I invented. So there's actually there's a whole debate in the space. Capabilities, I think Mark Miller was one of the first people who created capabilities back in the 80s, 70s or 80s. He has this website called eWrites that the idea at that time was capabilities were all local inside of a machine, giving the ability for different functions to have permission to call into other functions or not. And so spreading it over a network is a variant of capabilities where you're doing capabilities tokens for cryptographically signed communications, where we can verify by key that it's an authorized user making an authorized call. So yes, we created this particular variant of capabilities, but the model capabilities we didn't come up with that. And there's a big debate in the space actually about how insecure access control lists are. And this is the capabilities people basically assert all of our security problems come from wrong implementation because of access control lists. And they have this whole way, really pretty elegant way of illustrating the problem with this confused deputy problem, which I don't know if you want to hear that whole story, but it basically points out how bad access control lists actually are.
To manage the access control is the human error part kind of?
No.
Or no?
No, confused deputy is a program that has, so imagine, for example, one of the examples they use is a compiler sometimes. So imagine the compiler has the permission to write to a log, right, of its stuff. And that log is in a protected space with elevated permissions of some sort, right? So you say, hey, compile this program for me, but you set the target of the output to actually be its log file. So you compile a program, a malicious program, into the log file with the elevated permissions that can now run as the user that the log file had, right? And so you're tracking what I'm saying? I kind of went really fast on that.
It's like
But-
inheriting whatever it's in.
Right, and there's no way for that, they're calling it a confused deputy because the compiler you've granted it particular permissions, but it doesn't understand permissions, it just compiles programs. It doesn't know the nature of what it's doing, it doesn't know that you just set the output of your the compiled target to overwrite its log file or some other file that might have elevated permissions. It doesn't have to be even its log file. It has to be something it has permission to access. And obviously it can write to its log file, right? But if its log file is owned by root and you just compiled a program that lets you now run as root, for example, then you just took advantage, what's the word I'm looking for? Security term. You just took advantage of the compiler as a confused deputy to get around permissions that access control lists provide. And they give really detailed explanations of how it doesn't matter how good the human configures the access control list, because of the way computers work, they always create security holes. So the capabilities are the only way to actually get real security, which is part of why we've implemented cryptographic capabilities in Holochain.
So in that same scenario, the compiled program would then try and call some, elevated privilege, but if it would actually need the capability.
But it has that capability because
in that scenario, but if you were using capability-based security, it wouldn't matter because it would be in that spot.
That's right.
And it would try and call and be like, well, you don't
Exactly.
have this capability.
Exactly.
Yeah.